Again, my name is Bartosz Jankiewicz. I'm an engineering manager from Google Cloud Composer team. In the talk, I will cover an IAP 59, both idea, progress, design, inspiration, how it can help you, the users, how it can help the community to produce good quality product. And jumping to myself, for the last 3 years, I've been working in Cloud Composer team. Well, working on multiple features, so I won't mention all of them. Yet recently, I've been transitioned to another team. So my ways with Cloud Composer has diverged, although I will continue working on this project because I would love to see it, well, in completion. And also, it's been also motivating for me to, well, I would say, accelerate the work due to this presentation and also have the product, the performance management product, being released, well, soon after the conference. So, about the motivation. So let me jump quickly to a very quick summary of what IAP 59 proposes. So it aims to deliver a performance testing framework. So it's not about improving performance. It's also not about measuring performance, because there is no such thing as a kind of, well, universal way of measuring performance in case of products as complex as Apache Airflow. I mean, you could be measuring the duration of a task, SLAs, whatnot, but the problem with that is that there are so many factors that you need to take into account that the only thing you can actually reason about those kind of marginal changes in performance. And this is something you want to observe, right? So the benchmarks across the versions. And well, this is what IAP 59 covers, right? So how we can collect information about various metrics so that performance regression can be observed and documented, right? For instance, with the release notes. So the goals of this IAP, of this challenge is, well, first of all, measure the performance changes between Airflow versions, but also, well, I covered Airflow versions, but practically it's not limited to that. As also the last point says, it can also measure the changes between your own deployments. Like, for instance, you are changing deployment from, I don't know, nodes based on 5 cores to 6 cores, and what's the impact? Like, for instance, right? Maybe even more realistic example, you are upgrading PyPy libraries. Is there a performance regression? That's actually quite frequent observation, right? That some small changes have a butterfly effect on your overall product reliability in a sense of performance. And well, some real stories actually. So in Cloud Composer, we are helping to run in a reliable manner thousands of customers. So for us, performance regression for our customers, but well, transitively for us means a massive headache. So we observe such headaches, like for instance, when moving from Airflow 2.1 to 2 to 3, it's been observed 30% higher compared to Airflow 2.2 or 2.1 memory consumption. So what it means, for some customers, jobs started failing immediately. So it's not even performance regression, it's a huge failure. Because usually users don't leave huge buffers on the workers because they want to save cost, right? So 30% means practically a failure. We don't want to learn it from the customers. Well, second example, migration Python 3.8 to Python 3.11 also introduced 10% higher memory consumption. Memory usually is one of the key challenges, but well, if it was for CPU, it would be a similar problem. Now about the design principles, so how this framework has been designed. And by the way, the elements of this framework are already running at Google, have been running at Google, so we are porting this framework to community, to open source it. And well, this process is quite advanced, so we've simplified it, we adopted it to the way it can run with the community and also with your own installation. So what it means, we cut all Google-specific stuff, just sharing the things that will be important for you. Like, for instance, the initial framework was running, storing metrics predominantly in BigQuery. We don't want you to be coupled with BigQuery. We just want you to be able to collect the metrics. So first of all, we want to focus on something that is Airflow specific, but not third-party code specific. So this framework is not here to measure, I don't know, performance of particular operators. So we don't care actually what the operator does. We care if the given Airflow installation can run 100 tasks within a given time frame and what would be the memory consumption, CPU consumption, what's not. So usually the tasks being used in the framework are very simple, basic, so that they don't add this overhead, additional footprint, something like Bash operators, Python operators. Extensibility is the second thing. So supporting various Airflow setups. Again, because we don't want this framework to be coupled with Cloud Composer, wouldn't make sense for the community. We want to be extensible so that you can run it using Docker, Docker Composer, Docker Compose, Kubernetes, Elastic container service, whatnot. And configurability. So the testing should be also adaptable to your needs, right? So the configuration, well, is related to how your scenario is configured, how the DAC is configured, right? So how many tasks need to run in a performance test, how they are structured. So is it linear? Is it kind of parallel? Because sometimes you want to check if your setup can still run 1,000 parallel tasks, for instance. And also what is your setup in this test? 10 nodes, 1 node, number of CPUs, memory. So it's all configurable. And how? So there are three main, I would say, components, constituents to this framework. The first one has been released with the recent pull request. So, well, you can look into that. It's called Performance DAC. So it's the smallest part of this framework, which is a dynamic DAC that constructs number of tasks that can be shaped in a different manner, right? The shape of the DAC allows you to test different scenarios, such as, I don't know, can I run tasks in parallel? Can I slowly ramp them up? Like, for instance, I will share some details on the slide. And what kind of task would it be? So Bash operators, Python operators. And the performance DAC is configurable through environment variables. Second thing, the bigger one, is the instance. So this is the next PR that is going to be released soon. And the instance, I will cover also the details, but in the nutshell, it defines the setup of Airflow with all the, I would say, API to that setup. So instance also, as an implementation, includes specification how the Airflow should be deployed. Like, for instance, if it's Kubernetes instance, the implementation will cover all the specifications, how the Airflow should be deployed to Kubernetes. In case of Cloud Composer, the Cloud Composer instance implementation defines how the testing instance should be deployed using Cloud Composer API. And well, so this is the part that can be also extended, so you can also contribute to that. And lastly, the test suite is like a glue code, right? So your scenarios, Bash script, documentation that will be released along the way. So performance DAC. So as I mentioned earlier, some details. I haven't covered all of them. I just wanted to give you a gist of what it means. So the performance DAC can be configured with, for instance, how many DACs should be running in a test, how many tasks each DAC should have, what type of the task should it be, like as mentioned earlier, Bash operator, Python operator, but you can extend it with your own if you care for that for some reason. Importantly also, you may want to define this DAC shape, like there are a few predefined structures. So linear, like task will be executed one after another. So if you don't want to test, for instance, memory footprint that much, or you can, for instance, run them in parallel. So no structure means that all of them are being run in parallel. Of course, by using the limitation of Airflow configuration, like parallelism, worker configuration, so how many tasks a single worker can run in parallel. The next, I would say, complex thing is the instance. So the instance, as I mentioned earlier, is I would say, the meat of it. So how this setup is going to be executed. So instance implementation is practically a state machine. So it defines input to the test, like, for instance, number of workers, number of schedulers, a number of cores. Those are just inputs, placeholders, right? But what instance defines is actually how the states should be transitioned throughout the test. I will give you an example on the next slide, what it means actually practically, based on the existing implementation that is coming soon. And each instance defines the state map, which defines, well, how one state transitions to another. And each state is accompanied with three properties. One is the method that executes the state transition. Example would be starting state has a transition method of, well, deploy. So create the instance, right? And then it's waiting until it's created. And once created, we can upload the DAC. So that would be the next state. Retryable, so some states, and actually most of them, you want to be retryable. in case of failure, but some of them maybe not. And sleep time, so that you can, well, reduce some, I don't know, just testing overhead. For instance, if you deploy, you will assume that the deployment would take a good couple of minutes, so you don't want to check on this next status every second. Probably it will be more effectively to check every minute. And state transition method, well, returns the value for the next state, as I mentioned earlier. Yeah, so example, very simplified example on an existing state. Some more convoluted example will come next. So like for instance, I would have divided the state transition into phases. Like it all starts with the first instance setup when we want to create a cluster. It's also configurable in this test framework that the cluster can be, I would say, long-living, right? Pre-configured. So you don't want to create a cluster with the next every single test. So something similar to integration testing, right? So the setup method could be shared across the multiple tests. So that's why it's optional. Then you can deploy Airflow. Transitioning to the next state is validate. So validation method could check if anything can run, right? So is it healthy? And then you can upload the DAG. You can execute, well, actually this instance will upload the DAG. It will execute it. And it will observe until the completion. So once completed, the next state will be wait for the metric collection. It's also implemented as the part of the instance. So again, it's not like a simple test, like A/B test, like collect only the duration. The number of metrics that are being collected currently in the implementation is like few dozens. So number of CPUs allocated, memory allocated, memory utilized, CPU utilized, disk usage, whatnot. So dozens metrics like this, and also for each separate component of Apache Airflow deployment. A saving result actually means that we need to store them. We simplified to as much as we could, so it means that metrics are stored in CSV file, simply, so that you can, well, upload it to any storage solution later. So just to give you also some gist of what it means from the code side, this is what actually the implementation of the state machine could look like, right? So transition of each subsequent state and what methods will be executed for each one of them. Which means that actually the implementation of instance is fairly straightforward, right? It's not an interface, it's just implementation of states that you need to, well, produce if you wanted to have your own custom mechanism. And some more convoluted example with happy path in case of Cloud Composer. This is what it looks like. I just cut some non-happy path because from each state we can have a failure also where we just, well, tear down the cluster and maybe try again, right? So depending on what you want to do. Yeah, so metrics depend on the environment type. So again, you may have different metrics from AWS, different from Kubernetes. So it's up to you. It's also configurable in the framework what columns, so what metrics you want to store in the resulting CSV file. So typical sources of metrics that's being collected right away as the configuration that you have, that is input to the test. So all the inputs, and next to the inputs, the framework collects all the outputs, right? So the measurements of memory, CPU, disk usage, whatnot, being exported to a CSV file. And lastly, well, how to use it, integration. Yeah, so this is the brief idea of what the integration could look like, or maybe should look like. So first of all, it's unlikely it's going to be used for each run because it's too complex, it's too, I would say, too heavy to have it run for every single PR. But for instance, we may mark some PRs with tags like, I don't know, potential performance regression, better to test it. More likely that framework will be used for nightly builds, either for Airflow or for your installations, right? So the framework is not only for Airflow itself, but also for installation in your company. So whenever you want to upgrade, perhaps it's better to run a performance test to make sure that you are not introducing any regressions. Next, from the output, the metrics should be collected in some columnar store. So that's what I mentioned in this green box, metric storage. It could be any database that you can query so that you can produce reports, check regressions between versions, between runs to make sure you don't have any. And that will impact your release process, like maybe just a check mark, no regressions. Or you may decide to release with regressions, right? Consciously, that, well, you need to increase the memory amount because we have observed the change. Yeah, so integration. I think I will skip forward quickly because we are about to run out of time. Yeah, but this is rather straightforward, something I have already covered. And about the roadmap. So here's where we are. So the performance stack has been released. Instance framework is in progress. It includes Cloud Composer and basic Kubernetes installation. It should be also expanded now in the next phase with solution collecting metrics from any vanilla Kubernetes installation. So this metric collection part that is, I would say, agnostic to installation needs to be added. And then it will be ready to testing. So that's something I'm predicting to be released this year. And also documentation. And lastly, when it's ready, the last step will include integrating it with Apache Airflow build process so that Apache Airflow documentation, release documentation, includes those informations. So how can you contribute? Well, so as mentioned earlier, so this collector of metrics from Kubernetes and other cloud solutions, that's something that is pluggable, and I would welcome some help also to contribute with that, because some basic Kubernetes state machine has been already implemented, but only without this metric collection part. Implementation of other than Composer and Kubernetes instances could be also added, like MWA, whatnot. So if you have any ideas or needs, yeah, you can contribute. And, well, reviewing the code is also always welcome.